Course is now being recorded.
Good afternoon, everyone. I am Kenny Voss, the Assistant State Design Engineer. It's my pleasure to welcome you to today's webinar, where we will share some case studies on some of Kansas City's alternative intersection projects. Before we get started, I have a few housekeeping items to go over. If you have called in or are watching a webinar in a group, please send your information or class roster to Patricia Barnes by email. We are recording today's webinar and will place the recording in Mo.U. Please stay muted during the presentation. The chat will be monitored and questions addressed after the presentation. The presenters will have their videos on, but we ask everyone else to leave their video off unless you ask a question after the presentation. At the end of the presentation, use the raise your hand function if you have a question, and then we will call your name to have you unmute yourself. MoDOT is pleased to have two national award-winning experts present today. I am pleased to introduce our two speakers from the Kansas City District. Josh Scott is a transportation project designer, and Ryan Hale, who's a senior highway designer. Before we start, I want to thank both of them for modeling the One Team and Be Better values by assisting with traffic modeling questions across the state. I will now hand it off to Josh for the presentation.
All right, thank you very much. Welcome, everybody. Have just a whole bunch of stuff to go over, and I hope that you'll find this presentation informative, and I hope that you'll be able to implement some of the things that you see today. Next. This first slide I'm not going to read, but I think it's really gets to the heart of what are we trying to achieve when we innovate, and really this workflow should really be applied to any time we are looking at geometric improvements at a location. The first part is really identifying what is the problem you're trying to solve. Beyond just, oh, we have a congested interchange. What movements are the problem? Oh, we have a safety problem at this intersection. What are the safety issues? And then trying to tailor the improvements to whatever those specific problems are. And then, of course, going through the design process, and documentation and in the final design. Next. But as we look specifically at implementing innovative designs, we found kind of three key aspects that really help a innovation be successful. The first one is that whatever problem location you're looking at has a well-known problem that the public recognizes and often complains about. Another key component is our traditional solutions just can't make them work at that location. And then the last piece is whatever innovation we're trying to implement with the data that we do have, it shows that it is significantly better than what the traditional solutions would be. And then, of course, we always need to work with our local partners to bring them alongside so that they are in support of what we are trying to do. And I think another key piece is the support of MoDOT management. We've amazing things with the support of MoDOT management, and so keeping your local management involved as well as the statewide management, so that they are not surprised by what you're trying to do. Next. So I'm not here to talk about what St. Louis has done, but we do want to recognize that there have been a lot of innovations across the state, and that we've from some of the innovations that St. Louis has done. Here's these next two slides kind of show some of the things that we have noticed over the years. Next. But if you have any questions about these, feel free to contact St. Louis. I'm sure they'll tell you all about them. Next. These next series of slides want to kind of recap some of the some innovations that have been around for a while, but are still relevant when we talk about innovation. This first one is Roundabouts. In the Kansas City District, we've used them quite a few times at interchanges, at rural intersections. The one in the upper right is actually a St. Louis example where they use a roundabout to build an interchange with a two-way outer road. Another innovation that we have openly stolen from St. Louis. But I think what's maybe, I guess, important to me about roundabouts is, having an approach where you consider them anytime you have an operational or safety issue. In our district, any rural two-lane roadway that we have right angle crashes, our default is look at a roundabout. When we're looking at our outer suburbs and our two-lane roadways where we have rear end issues, we look at the traffic volumes and see if it's close to warranting signals. And if it is, we start looking at a roundabout. Next. Now this one is kind of an interesting one. And actually the ribbon cutting is supposed to be in a couple weeks for this. This is actually a roundabout interchange that Ryan and I both opposed. It operated far worse than a traditional diamond did. The safety was quite questionable. We couldn't find any research on the safety of a six-legged multi-lane roundabout, and the data we could find for four-legged multi-lane roundabouts was very mixed. But the city was quite adamant they wanted a roundabout here, and so the bulk of the risk was on the city system. So we're like, all right, it doesn't impact the interstate negatively. We'll go with it. Ryan, did you have anything you wanted to say on this one?
Yeah, sure. Maybe this is I guess we haven't talked in detail about traffic modeling yet, but maybe we'll start on the flip side of maybe this isn't one that we're thrilled about the results, and oftentimes we're looking at traffic volumes 20 years out in the future, and so that's a discussion point to remember, that a lot of these alternatives that we're weighing against each other, we're considering problems that are there today and that might be there in the future. And so the stakeholders in this case felt that traffic growth in the future might be a problem to solve later, but there's not congestion today, so they were more open to maybe the capacity constraints of this roundabout. Roundabouts, just as a quick point, in the traffic modeling scenario, they're really nice. One of the drawbacks maybe is that as they hit a certain capacity, it's very hard to fix those problems without other alternatives like maybe signalization, metering, things like that. So that's one of the things about roundabouts, is that in the future year analysis, it almost always works out that, oh boy, we really would have liked a single lane roundabout here, but it's just quite, it doesn't quite meet the threshold of levels of service. So these are all things to consider with alternatives.
Thank you. Another current favorite is J-turns. We have implemented quite a few of these on the rural 50 corridor in our district. There's a lot of ways you can go about building a J-turn, short J-turns, long J-turns, lefts in allowed, left ends prohibited. My personal favorite is the short J-turns, but the MU's research on the J-turns showed that longer J-turns were generally safer. So whenever we can, we try to build our J-turns long, but the site-specific characteristics, don't always allow for that. Something new that we've started doing with J-turns is actually on US 169 on the north side of our district, where to the south of this section, US 169 is a freeway, and to the north is a 5-lane signalized arterial. And so we have kind of this transition area where it's, not a freeway, but not a arterial. It's truly an expressway. And so we've got a lot of development going on in that area, and we've actually got the developers have built one J-turn, and we're in negotiations with another to build another J-turn to act as kind of a transition from a freeway to a signalized arterial. Next. And then here's one of the J-turn locations on 50 Highway. And just this slide is really just to highlight how over the years we've tried different things to fix our crash problem at US 50 and Mo 131. You know, we added turn lanes, then we added the offset lefts, and then finally we've gone to the J turns. And if somebody finds something better than a J turn, I'm sure we'll implement it here as well. Next. Then of course we've got the flavor of the month, Diverging Diamonds. Here in Missouri we've implemented a lot of them already, but there's always still something to learn, and ways to do things better. One of the things that we were able to take out of the safety study conducted by MU on the safety of DDIs is we've started squaring up our right turns from the off ramps so that they have better visibility, trying to reduce the rear end crashes that they were observing at some of our early DDIs. The example you kind of see on the top, we were not able to square it up very much, and so it still has kind of that large view angle that the drivers have to look if they want to make a right turn on red. The one on top is also kind of interesting in that the prior to building the DDI, there was a signalized outer road there, but it did not work as a signal with the DDI. And so we were able to actually do an alternative intersection using R-cut, or also known as a 3/4 access, to accommodate the DDI. Next.
I might jump in just real fast
Go
to
ahead.
say this DDI is maybe a little different than others in that you'll notice kind of a third signal. Just a real quick plug that this one was one where we used our traffic modeling program and found that the DDI was a nice fit, but it really struggled with the queuing in between the ramp terminals when it was sort of a normal DDI, if you will. And so what we found was with this skew that it was on, it really worked nicely to stretch it further to the west where there weren't other nearby intersections, and then kind of create this extra intersection where the southbound left, it's a new two-phase signal, but it's sort of a variation on a DDI, but not tremendously different.
And then this slide just talks about some of the challenges with a DDI. Probably one of the biggest ones is the maintenance of traffic. Anytime you convert from one traffic control type to another, there's that challenge of switching from the old pavement to the new pavement. And DDI is no exception. And you really have to be mindful of making sure you always have pavement in place for them to traverse during your construction. Another interesting piece of the DDI is the turns. Do you signalize them or do you have them yield? Or I understand that the Springfield has even implemented flashing yellow for the left turns, which we haven't done in our district yet, but I would be interested to see if there's maybe some locations that would be good for us to try that. And then the whole right or left turn on red. Kansas City is kind of interesting in that the city has an ordinance allowing left turns on red, and whereas the state does not. And so far we've decided to remain silent on the issue, and I have not heard any feedback that there's been any problems. And so I think we will continue to maintain silence on it, but someday hopefully we can get a statewide left turn on red law passed. And then the other aspect is anytime you have turning or curved movements, you have to be aware of your design vehicles. With a lot of these interchanges occurring on the interstates, there's a lot of large semis, and so you have to be aware of their tracking movements and making sure that they can traverse the turns. Anything you want to add on this one, Ryan?
Yeah, this one's sort of a funny case study where on some of the DDIs or any project really, you hear the kind of the mindset that, oh, auto turn is very conservative, the truckers are professionals, there'll be no problems. Here was a case where we had a single off-ramp left turn lane turning into two receiving lanes. And originally there was a guardrail around this corner. And as you can see with the marks with this new barrier, that was problematic. And even though auto turns said that, oh yeah, they'll have a few feet to spare, it won't be a problem. that particular turning movement was a struggle. And so I think one of the maybe the directions we're going in the future is, really analyze guardrail versus barrier and think about future maintenance implications. And then also auto turn, how conservative to be. Can we do an envelope, maybe analyzing extra space for them?
Now we're on to the fun stuff.
Okay, so I'll talk about two project locations where we kind of married some of these different ideas. And I guess maybe it's important to know that, or stress that, making it look weird or different, certainly isn't the goal. We're just trying to build the most efficient thing that's safest for all the members of the public to get through. And when the traditional alternatives maybe aren't ideal, this is sort of the result. But certainly, we're not trying to be first just for the sake of being first, right? So that's one of the public comments that we've gotten a few times on some of these as we go to the public for outreach. But just thought I'd throw that out there, that it's always about the results and not the uniqueness of it. The top of the screen is a location at I-49 is the freeway and 155th is the arterial. And the bottom of the screen is US 50 is the freeway and mode 291. And I'll just go through some of the details on those jobs. The first example location, no pedestrian accommodations. It was in the STIP for a bridge replacement, and it already had substandard vertical clearance. It started as a conventional diamond, and the operations weren't atrocious during construction, but there's significant growth predicted on the west side, particularly at the interchange. You can see some of the volumes here. And again, the west side and the north side are heavier traffic volumes. So we wanted to really make sure when we looked at our traffic models that we were considering that in the future. You can see kind of that highlight on the 220 feet between the northbound ramps and the East Data Road. And that was really important as we looked at alternatives. So the program we use a lot of times is called VISM. And so one of the cool things about VISM is it's very customizable. It maybe takes more time to set models up, but the results maybe are more detailed and more powerful than some other tools. Not to say that VISM is always the right tool, but in this particular case, it worked out really nicely for us. So here are some of the alternatives that we looked at, and we would have done cost estimates for all these to try to narrow the options and figure out what would be best to do. Relocating the outer road, like you see on the bottom there, is sort of a common approach. In this particular instance, it was unfeasible because of the site constraints. There was a cell tower, I think, in the southeast corner, and so the right-of-way implications were simply too much. The other maybe common alternative with DDIs is the right in, right out, this acronym here. So you can see this East Data Road. There are no lefts allowed at that location. It's, again, a function of this distance to the crossover. When DDIs get built, generally the signals get further from the ramp terminals, so the spacing to the outer road is even more problematic. So that's how we kind of came up with well, why not use the roundabout as a way to flip the DDI back over, if you will. And then you have the DDI on the busier side of the interchange, whereas the roundabout, in this case, just a single lane roundabout over on the east side where there's single family homes and less growth anticipated. Here are just a summary of some of the volumes that we considered, and what this is trying to convey is that the volumes entering and circulating at the roundabout for a normal roundabout would have been much higher than with this divergeabout, if you will, combination of diverging diamond roundabout. So as you can lower the sum of the conflicting and entering volumes, you're going to be able to provide better levels of service longer, right? And less queuing, less delays. So the divergeabout, this proposed design reduces the conflicting plus entering volumes. And then another thing you'd look at is delay of vehicles, travel time. These are the MOE, the measures of effectiveness that VISM can provide us. Here's one of the public outreach displays we had. And in a minute, well, I think I can do it now. I will show some of the other material that we used on this job. So here is a video. This is again from VISM, and it's just demonstrating a certain movement from this interchange. So we wanted to demonstrate the unique movements for the stakeholders. And again, this is kind of the one that I talked about where the social media, some of the people say, oh yes, okay, I understand what you're trying to do. And others say, oh my gosh, what are you doing? You're just trying to be different, or, this sort of thing. But ultimately, what was attractive to us about this was, again, the bridge width and some of the other attributes that, roundabouts and DDIs can provide. Let's see. While I've got it open, maybe I'll show this drone video. And of course, all this stuff we're happy to send anyone afterward if it's not coming through particularly clear or anything. Some of these videos I'll show are actually on YouTube, so you could certainly find them yourself too. So this little video, it's going to kind of rotate around, and so currently we're looking west. You can see down here on I-49, that's sort of an afternoon congestion issue of the freeway. And so here we're looking west on 155th. You can see the single lane roundabout here operating next to the DDI portion there on the west. This is maybe is a nice view of all the pedestrian facilities here. Again, this location, when we started the job, had no facilities at all, I believe, especially on the bridge. You can see all the shared use path there on the south side. And then as it crosses into the DDI, the path is between the two directions of travel. Maybe we'll talk about that for just a second, Josh. That's kind of a hot button thing, DDIs and having the PEDs in the middle rather than on the outside. Do you want to maybe talk about the history on that?
We were really uncertain of what to do with the pedestrians, because if you when you put the pedestrians on the outside, as is typical with any sort of interchange, you have a conflict with that free left movement that is just coming from underneath a bridge. And so we really struggled with what to do with the pedestrians, and really give credit to Springfield with their DDI, first DDI, where they put the pedestrians in the middle, where we could reduce the number of conflict points for all the crossings of vehicular traffic. But one of the downsides that we've heard quite a bit is, it's kind of uncomfortable walking in between two directions of traffic. And so I think there's a sense that an unease about having the pedestrians in the middle, but in terms of safety, I think it's the better way to go if you can pull that off.
Yeah, it's also interesting how some folks will bring up the fact that you're crossing perhaps twice to go through. And maybe the counterpoint to that argument is that there's shorter crossings and that the signal phasing is such that you're definitely going to get enough time to cross safely. So pros and cons to everything. I just wanted to quickly talk about signing. That's the kind of, one of the details that, this one was an in-house design that the core team kind of worked through and tried to visualize, think about where these signs needed to be, how many is too many, finding that sweet spot is maybe interesting in every project. And this was just later in the process, some of the changes, diagrammatic signs, or simplistic signs. Since this one was single lane, maybe it was really nice that we avoided larger overhead signs. So we've seen some of the videos on this one, and that one was open at the very end of 17. Okay, I'm gonna jump to the second Divergeabout location real fast. Almost all these bullet points are the same. And maybe I'll just focus on, again, it was in the STIP because it was a bridge replacement job and there were no pedestrian facilities out there. This location did have more congestion and more pedestrian use. But again, like the last location, it's busier on one side of the arterial than the other. So if you check out the volumes there, you'll notice the south side is significantly higher than the north. The north is sort of like the downtown area of this little suburb, and the south is kind of becoming expressway. The ramps again are heavier on one side than the other. It's heavier on the west side. So a lot of the heavy movements are northbound left and eastbound right. These were some pictures of the congestion in the previous condition. Morning and afternoon, there were some pretty good queues out there. It was a 5-lane bridge, 4 signals pretty darn close to each other. I guess 5th with the South Outer Road. Kind of like the last location, here are some options that we tested out in Vissum. Tighter mid diamond, single point diamond, offset left, DDI, loop ramp variations. The DDI was performed pretty well, but again, the struggle was this distance to the North Outer Road was just so darn short that it's very hard at a DDI, the way the signal timing works, to not trap people in the middle. And you're almost guaranteed to have a queue spilling into the DDI or from the DDI to the Outer Road. In a minute, I'll show you another display that kind of visualizes that. So kind of like the last location, thinking about the roundabout volumes conflicting and entering compared to a normal roundabout, this Divergeabout, using the DDI and then flipping the roundabout over was really nice at this location because of the traffic volumes. Again, we looked at delay and travel time of all those different alternatives to kind of narrow our alternatives to one preferred alternative. And then one of the interesting things about this location is a 2-phase signal here. And the reason for that is that we have 2 westbound left turn lanes. And so rather than treat that as a yield, we signalized that. And so, of course, we were cognizant of this distance and we didn't want any sort of queues to spill from one intersection to the next. So there were special detectors on this job to keep that area clear. And like the last one, signing was very important. This one probably even more so. Unlike the last one where a single lane roundabout sufficed with future year volumes, this one uses a multi-lane roundabout. So it's more complicated. You can see some overhead signing and the spiraling pavement markings associated with multi-lane roundabouts. I'll pull up some here real fast. I'll just show you this. Why not just build a normal DDI mentality? And I was talking about the difficulty since we're kind of looking northeast here. So this is the westbound ramp terminal. Since it's basically split phased, you'll never have the through movements going at the same time. So you're always going to have a really hard time keeping either southbound or northbound clear. It's especially problematic in a DDI when it spills from the outer road into the DDI, because of course one direction is blocking the other. Notice how this truck, is pretty darn close to preventing this car from getting through the interchange. Again, we did a Vissum model to show our stakeholders what this might look like. This one was really driven a lot by the city. They were funding a lot of this job, and so working with them was important, communicating these ideas. And again, it seemed like the overhead views are maybe sort of daunting for people. And again, that's we don't want to scare people, of course. So we found that these perspective videos that kind of walk through certain movements maybe are a little bit more effective at putting people's minds at ease about, okay, here's how to be signed, here's what lane you need to be in, that sort of thing. So I'll just let this play for a few seconds. It'll just kind of go up to the north side of the site. Josh, anything to add at this?
Nope, not at this point. All right, I changed my mind. I do have something to add. I think it's one of the things that's important to consider when you're looking at roundabout interchange versus a divergeabout interchange is the movement that has to yield. So at a typical roundabout interchange, the vehicles entering the interchange area have to yield to vehicles exiting the interchange area. But in a divergeabout situation, the vehicles exiting the interchange have to yield to the vehicles entering. And so if you have high through volumes, you have to be careful that you don't create a situation in a divergeabout where your traffic trying to get out of the interchange is blocking other movements.
Good point. Thanks for bringing that up. And so in this case, let's say hypothetically we had built a single northbound lane entering the roundabout. When we tested that out, we found really problematic queuing. And then, the drawback of that would be that, of course, the queue would spill to the south and then toward the DDI. And so that's why we ultimately went with the multi-lane roundabout in this location. This one was opened, I think it was mid-18 maybe. You can see here, same approach, drone video. Most of the biggest queuing that we saw previously was back in these areas, the northbound traffic. And since this is opened, I'm not aware of any congestion at this spot. The city was also really excited about this interchange project because they have high hopes for the nearby vacant land. So remember how we talked about that side of the interchange is already higher in volume, and then it's predicted to get even larger. So that worked out pretty nicely with this geometry.
And you'll notice that as the drone was going around, that there was a water park there, and that was one of the constraints on relocating the outer road. Is we have a railroad just to the east of this interchange, but then this park, and so we really couldn't move the outer road, and so the divergeabout allowed us to bring everything together into one intersection.
Yeah, that's a good point, Josh. That's kind of another common thread that those two example locations had, that relocating the outer road just wasn't feasible. I guess I didn't highlight the pedestrian facilities, but again, that was an important consideration on this one. You can see this light blue color, where again, they're sort of in the middle of this DDI, if you will, where they don't have to cross this free-flowing left turn. And that's definitely a location where myself and other pedestrians are enjoying the connectivity now. Okay, one more detailed alternative that we'll talk about. This one is kind of on the north side of the city. It opened in very late 2019, I think it was. And it's a displaced left interchange, sort of a cousin of a single point and a DDI, if you will. Before this interchange was done, there was significant congestion on the corridor. Here we're looking east of along the corridor at some westbound congestion, and then you can see the TMS crash map down on the bottom right. It's pretty zoomed out, the whole metro area. You can see this interchange area, it's 35 and 152, really stood out as an area that could have used some improvement. A lot of rear end crashes, which is maybe indicative of congestion. So like the other locations, we use traffic models to try to weigh some pros and cons, different alternatives. We looked at a traditional diamond, single point, DDI, and like every other job, it's not a magic bullet at any of these. None of these are, oh, DDI is popular this year, we got to build a DDI. It's all about traffic volumes and growth, pedestrians, all those attributes are site specific. Each of these had their own struggles, and the colors of the arrows are sort of color coded to say green was good and red was a challenge. So with the traditional diamond, the three-phase signal at the northbound ramps was problematic. because it's just hard to give enough time to the eastbound left, the northbound left, and the east and westbound throughs. So single points are often effective where you have a lot of left turning volumes. But unfortunately, our left turning volumes weren't really balanced in this case. We had a lot of northbound lefts, but not so many southbounds. So giving all that time to the southbounds, because when in a SPUI, of course, they're concurrent with the northbounds, wasn't really very advantageous. And also the clearance intervals in SPUIs are very challenging. This one's also on a skew, so the bridge would have been ginormous. The DDI at this location really struggled because the east and westbound through movements are both really high. In a lot of locations where we have success with DDIs, it's because the volumes are really directional. They're not balanced throughout the day. But here, if you have a high volume in each direction, they basically have to wait on each other at some point, right? You can't have both directions getting green simultaneously. So the DDI at this case didn't really work out. So by looking at a lot of different layouts and just kind of brainstorming, we came up with this sort of combination of Frankenstein, if you will, of trying to improve the conditions. So what you're seeing now is a video from VISM. The top is the traditional diamond interchange and the bottom is this displaced left. And they're more or less synced up. As you can see, you know, the eastbound is starting to get progression here and flow through the interchange and the adjacent outer roads. This was a location where our outer roads were a lot farther away than we have in other locations. So that definitely changed how we approach this one too. Notice on the traditional diamond, this eastbound queue is really starting to grow. Whereas this displaced left, where there's different signal phasing, is a lot more efficient. Rather than 3-phase signals at each ramp terminal, we're able to move traffic a lot quicker and safer. So it was pretty staggering differences in this case, where we had a lot less delay in travel time and a lot more vehicles were able to get through with this displaced left geometry. I'll show, here's a drone video of this one. So we're looking north here. So again, the two rings of this controller are each 2 phases. So really what's happening at this intersection and this intersection don't impact each other. So that really helps signal timing. It's really easier to give good signal coordination all the way down the corridor that way. And then what's unique about this east side is that, again, your lefts don't block each other, much like a single point, because this, in effect, is your southbound left, and this is your northbound left. Of course, they get green time at the same moment, right? They're concurrent. So again, that helps your capacity, helps your signal timing, and it's a bit unique because of this crossover movement that you see going right now. And one of the unique things at this location and sort of a lesson learned was we knew that we wanted to do a blank out signal for this northbound right turn because we didn't want them to go right on red during this crossover phase. So if you can imagine, if you're the driver of these vehicles, you're looking over your left shoulder to look for gaps in the eastbound through. We didn't want them looking that direction while this southbound crossover was getting green. So what we've done there is change the sequencing of the signal to make sure that every time the northbound right is ending, then the southbound crossover comes on, and that's when the no right turn on red is illuminated. So sort of a lesson learned that we hope will help safety out there for sure. I think we also had a similar VISM video. So just like the other ones where we wanted to focus on certain movements to kind of demonstrate to folks how they would drive it. It's kind of funny at the public meeting for this one, if my memory serves correct, you know, some of the ones with roundabouts, people are a little bit more hesitant about. For whatever reason, roundabouts are more daunting, but DDIs, at least in this part of the state, folks have really bought in. And when we showed them this video, it was actually kind of funny that we had to convince them, well, actually, it's not just like a DDI. because when they saw this, they said, "Oh yeah, I know that. You know, I do this movement. I've done that interchange before." So it was kind of a unique situation where we talked about the similarities and a little bit of the differences. Anything else on that, Josh, before I hand it back over?
Nope, I think you covered it all. And so then we're going to wrap up our presentation talking about some other innovative things we've done, as well as some things we've thought of but haven't been able to accomplish. So this first one is an interchange up north, actually just interchange one south of the one we just talked about at US 69 Pleasant Valley in I-35, where we had this antiquated design where the ramps were in the middle of the interchange, as you can see on the left side. But having a crossroad with another arterial coming in kind of from the corner really presented challenges of, okay, so how do we get all these movements to and from the ramps to 35? And what we came up with was actually, we put 3 of the ramp connections on the east side of the interstate, and then the 4th one is on the west side. Next, please. And so, like all these others, we looked at, every sort of variation we could think of, single points and that sort of thing. And we settled kind of on this, variation of an offset single point interchange. Like I said, where we put 3 of the ramps on one side and 1 on the 4th. Anything you wanted to add on this one? Next. And this one's maybe a little bit different slide. This was a project we were doing on I-435 on the south side of Kansas City. And we have several closely spaced interchanges. And so we were trying to figure out, okay, how do we accommodate, all this on and off traffic? And, the traditional solution is to do a CD road when you have closely spaced interchanges. And so the top alternative 1, you can see the CD road that we were looking at on the eastbound direction. Then alternative 2 is just the traditional on and off ramps with aux lanes. And what we were really surprised to find out is that with a CD, it actually worked significantly worse. You can kind of see the speed graphics there at the bottom left, where green is good and red is bad. The option with the CD was quite a bit worse than the traditional diamond interchanges. And what we discovered was that when we combined all of those ramps into a single entrance and exit from mainline, we were actually creating hotspots of traffic entering and exiting mainline I-435. And so we wound up we just basically left 435 with the closely spaced interchanges because it spread out the entrance and exits from mainline. Anything I missed on that, Ryan?
That sounds good. I guess one thing to consider is in that location, we had a certain project limit between a couple interchanges, but our traffic model really needed to extend on either side of it. Had we only modeled where we were going to build, we probably would have built a CD system. But because we included the interchanges up and downstream, that really gave us more insight as to the impacts that would have had. And actually, it was in Kansas, right? So you would have crossed the state line, and then welcome to Missouri. Here's a traffic jam for you.
Exactly. And then this slide kind of talks about, we've talked a lot about geometric changes, but sometimes there's other things that can be done to improve the situation. And the 2 examples shown here, we evaluated modifying the signal timing to allow certain critical movements to be served twice. So like in the bottom left, we allow that northbound left turn to come up twice in a signal cycle. Just allowing more efficient use of the progression and the available time to serve this problem movement. Ryan, anything you want to add on these examples?
I guess it's fun to do these gigantic jobs where the bridge has to be replaced, and there's millions of dollars on the line. Sometimes it's really impactful also to see spots like this that were on our scoping list for congestion issues, and then we can fix it in a week. after you're modeling it and stuff, maybe you don't need a wider bridge. Maybe you don't need, sometimes we have these thoughts in our head about, oh, we've got a traffic jam here, and by golly, I know how to fix this. We're going to do this and this and this. Maybe we can buy ourselves some time with something simple like signal timing.
And on these, it's important that you work with your traffic engineers because innovative signal timing requires sometimes specialized signal equipment that you may have to work through as well. So now we're going to wrap up our presentation with some great ideas that we had that have not been built. This first one was actually the one interchange north of where we built the Displaced left. We were looking to rebuild the I-35 and 291 interchange with a variation on a cloverleaf design. But federal highway concerns and our management got cold feet, and so we built a traditional diamond instead. It works great, but I always wonder how that previous design would have worked. Next. Now this intersection type is kind of unique, where the main intersection you don't allow any lefts. All the lefts are forced onto a quadrant road, so another road around the intersection. And what this allows is that your main intersection, which is often congested, to operate freely while you put all the left turning traffic onto this quadrant road, which is these secondary intersections are usually less crowded, and so you're able to give adequate time to the left turns. We've analyzed them in this type of intersection at a couple locations. It's never really risen to the top, but we keep our eyes open, hoping that someday we'll be able to fix something that can't be fixed by anything else with a solution like this.
And maybe something just in the weeds, maybe a little bit, but one of the things that's come up about this concept is that unlike the J-turn or the R-cut, where you're using islands that prohibit certain movements, with this configuration, you're really dependent upon drivers to not make a left where they physically can. And so that's maybe a pro-con to consider, where if people really want to make a left, technically they could. I think one of the interesting things that MoDOT's done in the St. Louis area was one of those through turns, which is maybe a variation on this, where you're relocating signal phases to increase capacity. So that's an interesting case where they're trying to make sure that people make those movements and don't cheat and make the left turn regardless. Maybe the St. Louis people are just better behaved than the Kansas City people. I don't know.
Somehow I have a doubt. And so this last example is actually at the I-70 and I-470 interchange, where we have a service interchange that's way too close to the system interchange. And so the traditional approach is to braid those movements to get the proper spacing. But our concept is to actually move the system ramps further away from the service interchange to provide better spacing. And in this instance, using a partial turbine configuration. And also kind of another interesting aspect is we're considering braiding the loop ramps. There's too much traffic on those two loop ramps to create a weaving section, and so instead we're looking at braiding them. At this point, this interchange has never risen to the top for funding, so it's still kind of waiting in the wings to see what we actually build here. But this is something we're still kind of kicking around as a potential alternative. And with that, we're done with the presentation. Do we have any questions?
Thank you, Josh and Ryan, for sharing these alternative approaches to these projects. These projects really demonstrate the importance of taking the time during the planning and scoping phase to make sure that we get the best value, obviously. And I think that takes a little bit of time up front, but obviously provides a lot of value at the end. So I think it's important for everybody to understand that. Also, it demonstrates the importance of having public involvement and stakeholder engagement. obviously you have to have buy-in anytime that you're doing an alternative project like this. So it's important that you use some of these modeling tools to demonstrate what it's going to look like, but also understand how you can use those tools effectively to communicate that. Because there's all kinds of ways of doing that, but sometimes it can, as I think Ryan said, a little bit, sometimes confuse people even more, but you have to figure out what the best way of demonstrating that is. So we'll take questions right now. Looking through the chat here, I do not see any questions at this time, but if you want to raise your hand under the reaction at the top right of your screen, you can choose to raise your hand and we can unmute you. Guess I do have a little question while we're waiting for some other comments. Josh and Ryan, can you kind of explain how you are set up in the Kansas City district? It's kind of unique and what allows you to do some of the innovative stuff that you're doing.
Sure. I guess what's kind of unique about our setup is that Ryan and I actually work in our design department, but we do all of the traffic analysis for our projects. And really where that grew out of is that while traffic, does do some traffic modeling, they're more focused on, today's concerns, what call reports are we getting today? Whereas, when we're looking at our projects, these are more oriented for, projects we're going to build, 3 years or 5 years down the road, looking at traffic volumes 20 years down the road. And so what we found at least in our district, is that the workflow of doing the alternative analysis actually fits better in the program delivery area than it did in traffic. And so I think that's really served us well in that, Ryan and I have been able to keep, close tabs on what our design projects are doing while doing the traffic type tasks.
And maybe I'll just add to that a a lot of times on little design jobs, maybe it's a resurfacing job, and oh, we know that there's congestion issues at that same location. Is it possible to restripe a spot? Is it possible to add a short turn lane? Can we get great benefit cost impacts out of some of these lower cost things? I guess technically a lot of those aren't as alternative intersections as these, but kind of just as important as the others.
There's a question in chat. I'm not sure if y'all can answer this or not, but it says, not sure if this has been discussed yet, but what factors caused the redesign of the Buck O'Neill Bridge?
Yeah, we were closely involved in that one for sure. The primary factor, I think, in that project was that, US 169 approaching downtown is a freeway. But then when it came to downtown, all the traffic ran into a signal there at I-70. And so our primary goal with the project, besides replacing the bridge, was to bring these connections from I-35 to 169 into flyover ramps, and so they can completely bypass the signal in a freeway to freeway movement. Does that answer the question?
And there were plenty of alternatives looked at for that one. For what it's worth, I was trying to be super cheap and get away from the flyovers, but that was an interesting one where the stakeholders, really had a vision of direct connections from one freeway to the other. So we use the traffic modeling tools to look at some outcomes and really wanted to explore all possibilities.
You all kind of explain when you start looking at projects in your district, when you get brought in.
It really depends on the type of project. You know, something like Buck O'Neill, we're involved, you know, even back in the environmental phase of the project, working with the consultant teams, you know, to develop the traffic models, and, you know, brainstorm alternatives, that sort of thing. But then sometimes there's projects, you know, like Ryan mentioned, resurfacing, and it just, you know, kind of comes up, hey, you know, we have a problem with this, you know, one signal. Is there anything we can do? And so, you know, we'll just kind of, you know, scrape together a model and take a look at it and say, if we, you know, build a, 200-foot right turn lane, you know, we can, you know, cut congestion by 20%, you know, and then, you know, the team goes, you know, down the road and tries to figure out if that's something that can be funded with the project. But really, you know, Ryan and I, you know, tried to, keep track of what's in the STIP, you know, for construction, what's in the STIP for scoping, you know, keep an eye on the unfunded needs list. And as we're aware that there are operational or safety issues, you know, we try to be involved early in the process, so that we can, you know, have the time to do a good analysis, and that the core team can do a good benefit cost evaluation of the improvements we're talking about.
All right, Charlotte, do you see anybody with their hand up?
No, I do not.
I do not see any additional questions in the chat. Do you all have anything else more to add before we close this up?
I just add that, you know, if anybody, you know, has any questions about anything, you know, feel free to contact us. If you're looking at something innovative and you know, like another set of eyes to look at it, we're always available to take a look. And you know, if you need some help with analysis, you know, we you know, can provide what help we can as our workload allows.
Right. Again, thank you all for this great presentation. So we will go ahead and wrap this webinar up. We will be registering you for participation in Mo.U. Teams allows us to track who is attending, but we do not know who may be attending by a group or call. So please email Patricia Barnes if you need to get credit for today's training, if you were not logged into Teams today. This concludes our webinar, and thank you for your participation.